Okay, the first thing I did with your assignment that I'm doing here is I'm changing this problem 6 here, this 1528. That's going to be extra credit because it is just that one's a bear. Okay, I'm sorry. It's just kind of crazy. And so we'll save and continue. They'll probably give me a warning saying this will affect nothing being with it. I don't care. Like I care. All right. And it's still going to be due at the same time. So let's save and finish. Okay, so that's been saved. Now let's go back to the organized content because that's the easiest way for me. So that one because what that does, it's one of those annoying things with a problem is that it to me it turns into a freaking hard algebra problem, which is stupid. Okay, sorry, it's taken me forever to get back to what we need to do here. All right, so let's look at 35 and 44. Okay, so let's look at those two problems, 35 and 44. We'll probably just look at 35 in this video. Well, there's your answer. Student data. You see the student data there? 6 out of the 90 of you have tried this one. So anyway, all right, so two very large parallel plates. And you guys have no idea what they're talking about when they talk about two large parallel plates. It's in your book, but I know that's, I'm not, and trust me, it's hard to read a physics book. I understand that. But here's the deal with parallel plates. All right, I'm going to draw two parallel plates. So here's what we've got. And you also are going to have to learn a new thing, the permittivity of free space. How's that for a mouthful? All right. Anyway, so I've got. I don't think I need to make this one this big because the print's not so bad. I mean, I need to make it a little bigger than that. No, that'll work. A little bit bigger. Sorry. So, well, shoot, you already got one problem turned into extra credit, so you can bear with, right? Anyway, all right. So here's two parallel plates. All right, and we're going to look at the total charge that are on each one and what a parallel plate does. And we're going to really get into this in the next chapter. Is okay. So you got a bunch of positive charge that is collected on this side. You got a bunch of negative charge down here on this side. This is a parallel plate. So we've got the electric field looks like this. All right. Now, since I have a captive audience here, so here's our electric field. And we are going to assume, even though you go, wait a minute, N equal to KQ over R squared, so we're going to assume that these plates are close enough that the E field is the same everywhere. We're going to, in between here, the E field's same. All right, uniform. So the E field is uniform throughout. Now, what we're going to learn in chapter 16 in the next chapter is that the voltage lines are very different because this is going from a positive voltage to a negative voltage, all right, on this side. But we'll look at that later. So we have the E field is uniform, and here's the deal. Here's the fancy, and the charge we're going to look at is just on one plate or the other. Because if we sum up the two charges, what does it equal? The net charge of the whole thing is what? 0. Right. So we pick one plate or the other. Here's the kind of, we take this line integral type thing of E. Now this is physics 460 that I'm throwing at you here. All right. Is equal to the total charge on one plate divided by this permittivity of free space. That's how much charge can travel in a vacuum. And E naught is another physical constant, and it's called 8.854 times 10 to the negative 12 farads, which you don't know about yet, per meter. I think our book uses a different connotation for, if I can find, I don't want to look it up right now, but might use a different, you don't know what a farad is yet, but you will. All right, you will. Basically, well, I know what a farad is because I know the capacitance, or Q, is equal to C times V. It's a volt. Farad is a volt per meter. So this is like, could be like a volt per meter squared or something like that. But it's farads per meter. That's not what you need to worry about. What we're doing here is the electric field. Then when we take this in, when we take the integral for dA, we wind up with EA is equal to the total charge on the top of the plate or bottom, depending on if you want to look at the positive or the negative. So when we compute this, is equal to that, and so therefore the E field is equal to Q over A times echo naught, or the total charge on the plate is equal to E times the electric field, E times A times echo naught. And I think that will help you a lot on that parallel plate type problem. All right, I want to make sure this is the one that we're talking about. Yes. What is Q over A? Well, you got it. All right, so it asks what is Q over A? Well, Q over A is equal to E times echo naught. that's what Q over A is. All right. Boy, I hope so. Should I try that? How much total charge is on each plate if they're 16.5 meters on a side? All right. This is the other tricky question. 16.5 meters on a side. What they mean here is that this is one side of the area of the parallel plate. So it's 0.165. In this case, it'd be 0.165 meters squared is your area. Okay, on a side. And some of you that may not be familiar with that kind of language, on a side means that you take 0.165 squared and you wind up with the area. Okay, and I'm going to double check, make sure that I got this Q over A right. What did they say? It was 2.2 e to the sixth is the, and notice the electric fields are huge. Electric fields are big. And times. Okay, I'm gonna try that little permittivity of free space thing. I'm gonna let you watch what I'm doing here. 8.854 second e to the negative 12. 1.77 times 10 to the negative 5. That sounds, I think we're in the hunt. And they want it in microcoulombs per meter, so that would be times 10 to the 6. Since they want it in, they do want it in the microcoulombs, bastards. All right, no, kidding. So I need to multiply that by, or divide by 1.0 times 10 to the negative 6. I'm going to multiply it by 1.0 times 10 to the positive 6. And I get 17.7. 2 sig figs, I'll say 18. Hoo-yah! I rule. Out here on that one.